In this video, I will explain how to solve a linear programming problem using the Excel solver. So let's jump right into an example. Let's say that we would like to maximize the function z is equal to 40x plus 30y, subject to the following constraints. So these constraints right here. To solve this problem in Excel, we're going to use the Excel solver. Now, if you click the Data tab along the top ribbon in Excel, you should see a group called Analyze where there's a Solver button that you can select. Now, if you don't see that button, then you need to install it. So to install it, click File, then go down to Options, then click the Add-ins on the left-hand side, then click Analysis Toolpack, then click Go. Now, in the window that pops up, make sure that Solver Add-in is checked, then click OK. Now, in your Data tab, you should see an Analyze group with a Solver button right here. That means the solver is installed. Okay, so now we're ready to set up our problem in Excel. So the first thing we're going to do is we're going to type x, y, and z. So the names of the variables in the maximization function. So we'll type those in row 1 right here. Next, in cell 2 and cell 3, we're going to type solution and coefficients. So for the solution cells, you can leave x and y blank. For z, we're going to type the following formula. Equals sum product of the coefficient values, comma, the solution values, and then hit enter. So right now we'll show as 0 just because x and y are both 0, but that's okay. For the coefficients, for x, we're going to write the coefficient in the current maximization problem. So that would be 40, and then for y, the coefficient is 30. Now moving down here, we're going to write out our constraints. So in this case, we have two constraints right here. So for the first constraint, we're going to write the coefficient of the x value, which is 1, and the coefficient of the y value, which is also 1. Now, for the left-hand side of this equation, we're going to use the formula equals sum product, then we'll select the coefficient values for the constraint, then comma, we're going to select the solution values for x and y, and then we'll close our parentheses. Then we're going to highlight B2 and C2, and we're going to type F4 to lock those cells, then hit enter. Now for the sign, that's just the sign in our constraint, which we can see is less than or equal to. So we'll type less than or equal to, and the value on the right-hand side of this constraint is 12. So we'll type in a 12. Then for the constraint number 2, we're going to repeat the process where we say the coefficient for x is 2, the coefficient for y is 1. For this left-hand side, we can just click this formula that we just made and drag it down to this cell. Then again, the sign is also going to be less than or equal to, and on the right-hand side, we can see that value is 16. So now we're done with the setup. Now we can go ahead and solve. So let's click the Data tab, then click Solver. Now when it says Set Objective, we're trying to maximize in this case. So we'll leave max selected. We're trying to maximize this cell right here, this z value. So we'll click that. By changing variable cells, so the cells we're going to change are B2 and C2 in this case, so the solution cells, subject to the following constraints. So go ahead and click Add. Now in the cell reference, because both of the constraints have the same sign, we can just select a range of the constraints. So our constraints on the left-hand side are these two. The symbol that we'll choose is less than or equal to, and the constraint for that range is just the right-hand side values. And then we'll click OK. Then make sure that Make Unconstrained Variables Non-Negative is checked, and for this example, we're going to use the simplex LP method to solve it. So go ahead and click Solve. So we can see that the solution is shown. So x is 4 and y is 8. If you'd like to, you can generate something known as reports, so an answer report that will just show the x and y values, or a sensitivity analysis or limits analysis if you'd like to. I'm just going to leave all of these unchecked, and I'll go ahead and click OK. So that's our answer for this. This function is maximized when x is equal to 4 and y is equal to 8. And when x is 4 and y is 8, z is 400. So those are the steps that you can use to solve a linear programming problem using the Excel solver.